You know, when you buy a 1,000-piece jigsaw puzzle, you implicitly trust the picture on the box, right? Like you look at that beautiful, serene landscape, you dump all the little pieces onto your kitchen table, and you just assume, without even really thinking about it, that every single piece belongs to that specific picture.
Right, yeah. It's a foundational assumption for how we process information. I mean, you assume that if you can just find the four corners and sort out all the flat edge pieces, everything else will eventually just snap into place exactly as the manufacturer intended. You don't question the box, you question your own ability to match the shapes.
Exactly. It's super comforting. But imagine you've been working on this one specific puzzle for decades, generations even. You've got the edges done, you've got some major sections built, but there's this growing pile of leftover pieces that they just don't fit anywhere. They look like they belong to a completely different puzzle entirely. Like maybe a picture of a sci-fi spaceship or I don't know, a bizarre deep sea monster. And the more you try to jam them into your peaceful landscape, the more the whole picture just like warps and bends.
Yeah, and this is the classic problem of anomalous data in any scientific field, really. When pieces of evidence consistently refuse to fit the established paradigm, you are left with a fundamental choice. Like, do you force them in by creating increasingly complex mathematical workarounds? Do you just sweep them under the rug and call them statistical noise?
Or you finally question the picture on the box.
Precisely. Do you question the box?
Boom. That is exactly what we are doing today. We are taking the jigsaw puzzle of Earth's entire 4.6 billion year history, all the rocks, the fossils, the oceans, the literal moon in the sky, and we are throwing away the box. Today's deep dive is focusing on a radically alternative geological model called the Small Bang Theory, or SBT, as presented in our source material by author Arndt Meyer. Now, just to be super clear right up front for you listening, this is not the cosmic Big Bang that created the universe, right?
No, no, not at all. We are looking at a localized planetary event here. It's a hypothetical, catastrophic sequence of events that occurred right here on Earth, proposing a completely different mechanical timeline for our planet's evolution.
Okay, let's unpack this. Because our mission today is to embark on an absolute journey of discovery, I want you to look at the formation of our planet through the eyes of a young explorer discovering a completely unknown world. We are going to explore a theory that challenges the mainstream plate tectonics model from the ground up. We're talking about a model that proposes one single dramatic event created our moon, filled our deep oceans, gave us our seasons, and wiped out the dinosaurs all in one fell swoop. It's a mind-bending thought experiment. Like, what if everything we thought we knew about Earth's slow, gradual, peaceful evolution is built on the wrong assumptions?
It is a massive intellectual swing, I mean, without a doubt. Yeah. And it requires us to establish a very clear framework for our discussion today. Our goal here is to thoroughly analyze the source material provided. We are impartially reporting on the specific claims made by Arndt Meyer. We are not endorsing these claims as mainstream scientific consensus. I mean, mainstream geology relies heavily on plate tectonics, and paleontology relies on a very different timeline of evolutionary biology. Our job today is to explore the fascinating narrative of the Small Bang Theory, test its internal logic, and, dissect the mechanical physics it proposes.
Absolutely. We are here to be your guides through this incredible story. And to understand the explosion, the small bang itself, we have to go way, way back. Because before you can understand the explosion, you have to understand how the fuse was lit, right? And that fuse was lit 4.6 billion years ago in what the author described as the cosmic pressure cooker.
Right, and this initial phase spans an incredible amount of time, stretching from 4.6 billion years ago all the way down to 541 million years ago. So we really have to wipe away any image of the familiar blue marble we inhabit today.
Right. So, picture this. 4.6 billion years ago, Earth is a terrifying, glowing, molten ball of liquid heavy metals and lighter elements just spinning in the dark. It's like a giant drop of liquid fire. According to the source, gravity immediately started organizing this chaos. It pulled the heavy, dense metals like iron and nickel straight down into the center to form the Earth's core. Meanwhile, the lighter stuff, the silicate slag, basically floated all the way up to the surface.
Yeah, and the underlying physical principle here is just a basic density gradient. Heavy materials sink, lighter materials rise.
Yeah.
I mean, you can observe the exact same thermodynamic and mechanical process in everyday industrial metallurgy.
Yeah, like if you've ever watched a blacksmith or seen a video of industrial metal smelting, when they melt down impure iron in a giant vat, all the impurities, the lighter rocky materials, they separate from the heavy iron. This lighter stuff is called slag, and it floats right to the top, forming a crusty layer over the glowing liquid metal. The Small Bang Theory says the early Earth did the exact same thing, but on a planetary scale. The heavy iron sank to build the core, and the lighter silicate slag, which would eventually cool into granite, floated to the surface of this global magma ocean.
Exactly. And as this glowing sphere of magma and floating granite slag spun in space, it began to radiate heat and cool down. But, and this is key, the cooling wasn't uniform. The source material points out a crucial geometric factor for this ancient Earth. It was spinning perfectly upright. There was absolutely zero tilt to its axis relative to the sun.
Wait, upright? Like, meaning the equator was getting blasted with direct concentrated solar heat all day, every day, but the North and South poles were getting the absolute least amount of sunlight. They were the darkest, coldest spots on the planet.
Precisely. Because of this thermal disparity, the liquid slag at the poles literally froze into solid rock before anywhere else. The very first solid crust of granite formed at the upright north and south poles. And Meyer makes a highly specific, testable claim here. He identifies the oldest known rocks on Earth today, which are the Jack Hills in Australia and the Acasta Gneiss near Yellowknife in Canada, as the original north and south poles of this early Earth.
Wait, hold on. Let me push back on that for a second, because that sounds like a massive geographical leap. If we're throwing out plate tectonics, which is, the mainstream explanation for how continents drift, how does Meyer mathematically trace a specific rock formation in modern-day Australia all the way back to an original polar position? Like, what's the geometric proof for that? Australia is nowhere near the North Pole today.
It's an excellent question, and it really cuts to the core of how this theory treats planetary geometry. So in the SBT model, the Earth's crust doesn't slide around on conveyor belts of magma like it does in plate tectonics. Instead, Meyer argues that the crystallization of the crust was a sequential, fixed process. If you map the absolute oldest isotopic dates of rocks globally, you find the oldest dates cluster in these two specific regions, Western Australia and Northern Canada.
Okay, so the oldest.
Right. And in a purely thermodynamic cooling model of an upright sphere, the oldest solid material must mathematically originate at the points of least solar radiation. Therefore, Meyer deduces that regardless of their current latitude, which we'll explain later was shifted by the cataclysm, their sheer age proves they were the original poles.
Okay, I see. So he's fixing their original location based purely on the thermodynamics of a cooling sphere. So we have these two little skull caps of solid billion-year-old granite at the top and bottom of the Earth. What happens next?
Well, slowly, over billions of years, the planet continues to radiate its internal heat into space. As it cools, the solidifying granite crust begins to spread. It grows outward from the polar caps, creeping slowly toward the equator. Think of a hot water bottle that you've put in the freezer. It doesn't freeze all at once, right?
Right, yeah. The edges, the parts exposed to the most cold, freeze first, and the ice slowly encroaches toward the center. Or like a pond freezing over in the winter. The ice starts at the shallow edges and slowly creeps out until the whole surface is covered. So for literally billions of years, this solid granite crust is growing, spreading from the poles, leaving only the equator as an open, bubbling belt of exposed lava.
And that shrinking equatorial belt is critical because of outgassing. The early Earth was constantly releasing massive amounts of gas from its molten interior. We're talking water vapor, carbon dioxide, nitrogen, and various toxic compounds. As the solid granite crust closed in from the poles, these internal gases had fewer and fewer places to escape. They were all funneled toward the remaining open vents at the equator.
The author describes these open vents as continuous volcanoes acting like massive jet engines, right? Like they are just constantly blowing incredibly pressurized gas into the thick early atmosphere.
Yes, and the mechanical consequence of that is fascinating. Because the Earth is spinning, those equatorial jet engines are blowing out gas at an angle relative to the planet's rotation. The theory proposes that this continuous angled outgassing actually provided thrust, gradually accelerating the Earth's rotational speed over hundreds of millions of years.
That is wild. It's like a spinning firework on the ground. The more it spews out the side, the faster it spins. But eventually, the pond freezes over entirely. The ice closes. Those jet engines get capped.
Exactly. And the data in Meyer's model pays this complete global closure at exactly 541 million years ago. At that moment, the final vents at the equator sealed shut. The Earth was now entirely encased inside a solid, continuous, unbroken shell of granite, estimated to be between 20 to 60 kilometers thick.
And as that 60-kilometer thick granite shell finally closed around the entire Earth, it created a massive, inescapable trap. The gases generating inside the planet's molten core had nowhere left to go, which fundamentally shifts the entire operating system of the planet. We transition from a cooling, outgassing rock into what the author calls the boring but incredibly pressurized era of Earth's history life in the greenhouse.
Right, and this era spans roughly 475 million years, from that 541 million year seal mark down to 66 million years ago.
But I have to ask about the physics of that seal. Like, how does rock seal perfectly? Granite is porous, it has microcracks. If you have a planet full of expanding superheated gas, why didn't it just leak out slowly, like a slow puncture in a bicycle tire?
That's a crucial detail. Meyer addresses the porosity of granite with a fascinating chemical mechanism. As the pressure inside the Earth began to build, the escaping carbon-rich gases and fluids were forced up into the microcracks and pores of the newly formed granite crust. But they didn't just pass through. Under that immense heat and rising pressure, these carbon fluids essentially baked into the rock. They precipitated out, forming solid deposits of carbonate, graphite, and quartz within the fissures.
Oh, wow. It's literally like using that tire repair spray, the Fix-A-Flat foam you buy at the auto shop. When you spray it into a punctured tire, the liquid finds the hole, hits the outside pressure, hardens, and seals the leak perfectly. The Earth was effectively using its own internal carbon to caulk every single microscopic crack in its 60-kilometer-thick granite armor.
The analogy is mechanically sound, yes. The Earth became a perfectly sealed, high-pressure vessel, a planetary pressure cooker. And inside this vessel, the SBT claims a profound chemical transformation took place. The author argues that the trapped heat and pressure, acting on the carbon-rich gases inside the Earth's mantle, turned the entire planet into a giant natural chemical refinery.
This completely upended everything I thought I knew when I read it, because we are all taught in school that fossil fuels like coal, oil, natural gas are made from dead dinosaurs and crushed ancient forests. Biomass that got buried, compressed, and cooked over millions of years.
Right, the universally accepted biogenic theory of fossil fuels relies entirely on that mechanism. Surface life dying, sinking, and transforming over eons.
But the SBT completely throws that out the window. The source claims that through a process called Fischer-Tropsch synthesis, the Earth endogenously created coal, oil, and gas directly from the outgassing carbon trapped under the crust. It was an abiotic process. The Earth synthesized its own oil and coal without a single leaf or dinosaur needing to die. Is that even scientifically possible?
Well, we should look at the chemistry of that claim, because the Fischer-Tropsch process is a real, well-understood reaction. It is actually used in industry today to convert carbon monoxide and hydrogen into liquid hydrocarbons. Meyer's theory posits that the specific parameters inside the sealed Earth provided the exact necessary components for this.
Okay, so what kind of component?
You had immense rising pressure. You had temperatures in the thousands of degrees. You had an abundance of transition metal catalysts like iron and nickel in the magma. And you had a cooking time of nearly 500 million years. According to this model, these are the perfect conditions to naturally synthesize vast reservoirs of hydrocarbons deep underground, completely independent of organic matter.
But wait, what about the fossils? Mainstream geologists point out that we literally find traces of ancient plant matter and biological markers inside coal deposits. How does the SBT explain that if the coal was cooked up from pure magma?
The author provides a counter-explanation for that specific anomaly. He argues that the traces of plant and animal matter found in coal today are merely surface contaminants. Remember, in this model, the crust eventually violently ruptures. During that reshuffling, surface swamps and biological matter got folded into these deep, abiotic carbon deposits. So from his perspective, the biological markers are the debris caught in the oil, not the source of the oil itself.
That is a massive paradigm shift. It completely changes how you look at a lump of coal. It's not a compressed fern. It's a baked chemical precipitate from the Earth's mantle.
Okay, so we've got the sealed pressure cooker churning out oil deep underground. But what was happening above ground? What was the surface of the sealed greenhouse like during this 475 million year stretch? Let's paint a picture for you listening. To accurately reconstruct this world through the lens of the small bang theory, we have to look at what was fundamentally missing compared to our modern environment. First, and arguably most importantly, there was no moon.
No moon. So because the SBT models an upright, moonless early Earth, we're looking at a completely static physical environment. No lunar gravity pulling on the planet means absolutely zero ocean tides. The water wasn't churning, it just sat there.
Furthermore, the Earth's axis was still perfectly upright. Zero axial tilt.
Which means the sun hits the exact same latitudes at the exact same angle every single day of the year. There was no seasonal selective pressure, no summer, no winter, just a constant, unchanging climate band that only varied based on your proximity to the equator.
And physically, the landscape was radically different. The source asserts there were no deep oceans. Because the planet was covered in a continuous, unruptured, relatively smooth granite crust, the water simply pooled in shallow depressions. The maximum depth of any body of water on Earth was merely 500 meters. The global landscape consisted of shallow, warm swamps, massive flat lakes, and low-lying landmass.
It was a completely flat, stagnant world. And the atmosphere was wild. Because the Earth was a smaller, denser sphere, since the crust hadn't lost mass or expanded yet, the gravity at the surface was slightly stronger and the atmosphere was incredibly thick. The source estimates the atmosphere stretched up to 1,000 kilometers high.
Yes, and for context, our breathable atmosphere today is mostly concentrated in the first 15 to 20 kilometers. This ancient atmosphere was a dense, heavy soup.
Yeah, the air pressure was immense, maybe 5 times what we feel today. It was a hot, humid, high-pressure terrarium.
And what's fascinating here is how the source connects the physical constraints of this thick greenhouse world directly to the biomechanical and evolutionary traits of the animals that live there, specifically the pterosaurs and the dinosaurs.
Oh, the pterosaurs are the perfect example. I've always wondered about them. You look at fossils of these massive flying reptiles, some the size of small airplanes like Quetzalcoatlus. Their wings look ridiculously small and fragile for their immense body weight. Mainstream biology has debated for years how they could possibly generate enough lift to take off, let alone fly long distances.
Right, it's a known aerodynamic paradox in paleontology, at least if you assume modern atmospheric density.
But in the SBT model, the paradox just vanishes. If the air is a thick, dense, high-pressure soup, you don't need giant, powerful wings. Flying in that atmosphere would be mechanically closer to swimming. A tiny wing could generate massive lift because the fluid medium, the air itself, was so dense and supportive.
Meyer uses these environmental parameters to brilliantly resolve the biomechanical anomaly. Furthermore, he uses this perfectly stable, unchanging environment to explain the general evolutionary trajectory, behavior, and even the intelligence of the dinosaurs.
Yeah. The author basically calls the dinosaurs sluggish and dumb. And he doesn't mean that as an insult, he means it as an evolutionary reality. Think about it from a survival perspective. If you live in a world where the temperature never changes, there are no seasons, the water levels never fluctuate because there are no tides, and you live in an endlessly warm, shallow swamp, well, you don't need to be a clever planner. You don't need to migrate hundreds of miles to follow the food. You don't need complex problem-solving skills to survive the winter. You just stand there in the warm swamp, eat the abundant vegetation, and grow massive.
Exactly. In evolutionary biology, selective pressure drives adaptation. A simple, static, stress-free environment breeds simple, static animals. There is no environmental stress forcing the development of high intelligence, complex social structures, or rapid adaptability. The dinosaurs, in Meyer's view, were the perfect biological expression of a perfectly stable pressure cooker. They were highly optimized for a world that simply never changed.
It's like playing a video game on the easiest tutorial mode for 400 million years. Nothing ever challenges you, so you just get really big and lazy. But a sealed pressure cooker with a molten core generating heat and outgassing carbon continuously, it can't stay stable forever, right? The safety valve was cocked shut with carbon. The pressure was mounting to an absolute breaking point.
Which brings us to the mechanical failure of the crust, and really the most violent moment in Earth's history, the cataclysm that defines the Small Bang Theory.
The day the Earth popped.
The timeline proposed is highly precise, exactly 66 million years ago. Deep inside the mantle, the continuous outgassing and the thermal expansion from the core had built up an internal pressure that Meyer calculates reached between 6,300 and 6,500 bar.
Wow. Okay, to put that 6,500 bar into perspective for you listening, the pressure at the very bottom of the Mariana Trench today, the deepest, most crushing part of the ocean, is about 1,000 bar. This internal pressure was over 6 times that, and it was pushing outward uniformly against the solid 60-kilometer thick granite shell of the entire planet.
And rock has a specific tensile yield strength. It can only withstand so much outward force before the molecular bonds begin to fail. The granite crust could no longer hold. It had reached its absolute mechanical limit. The theory states that the rupture logically occurred at the thinnest, structurally weakest point of the crust, which was located at the equator, specifically corresponding to the modern-day Pacific Ocean region.
I want you to picture shaking up a bottle of warm champagne for about 400 million years and then finally prying off the cork. The author actually calls this the Sektflaschen effect, the champagne bottle effect, but playing out on a planetary apocalyptic scale.
The thermodynamics and mechanics of this sudden depressurization are staggering. The exact moment the equatorial crust cracked, it triggered a catastrophic chain reaction. The sudden localized drop in pressure caused the trapped, superheated gases and the volatile elements dissolved in the magma to undergo a violent phase change. They expanded and boiled out all at once. Gas, liquid magma, and shattered continental-sized chunks of the granite crust blasted out into the atmosphere at calculated speeds of 9.5 to 13 kilometers per second.
Wait, 13 kilometers per second? That is over 46,000 kilometers per hour. That is faster than the escape velocity of Earth. That material wasn't just being shot into the upper atmosphere, it was being shot completely off the planet, into the vacuum of space. And this wasn't just a single quick pop like a firecracker, right?
No, the physics of depressurization dictate a multi-day self-reinforcing ejection process. As the crust tore open and ejected material, the pressure in the underlying mantle dropped further. This pressure drop caused deeper layers of magma to instantly boil into gas, which fueled massive internal chemical explosions, which ripped the crust open even further along the fault lines. It essentially unzipped the planet along the equator.
And we have to remember the Earth was spinning, so this equatorial rupture acted like a massive, continuous jet engine firing sideways into space, adding a rotational slingshot effect to all that ejected rock and magma. But wait, I need to push back here. Let's talk about the physical shape of the planet. If the Earth essentially exploded from the inside out, ripping its crust open and violently outgassing, didn't the planet expand? If you blow up a balloon, it gets bigger. If the pressure was pushing outward so hard it broke the crust, surely the Earth's circumference increased.
It's a very intuitive assumption, actually. In fact, Meyer notes that earlier iterations of alternative geological theories, like the expanding Earth theory, assumed exactly that. But based on the mass ejected and the physics of gravitational settling, the current small bang theory is actually a strict reduction theory.
A reduction theory, meaning the Earth actually got smaller after it exploded. How does a solid rocky sphere shrink globally by 40 kilometers without just collapsing into a totally liquid, formless mess?
The mechanics rely on the sheer volume of mass lost. During the small bang, the Earth lost an incredible amount of material gas, magma, and vast sections of the solid granite crust. Meyer estimates the Earth lost between 2% to 3% of its total planetary mass in this single multi-day event.
That's a huge amount of material.
It is. And when you remove that volume of material from the rigid outer layer and the pressurized mantle beneath it, a massive void is created. Gravity immediately pulls the remaining fractured plates of the crust inward to fill that void. Because the planet lost this massive volume of lighter crust material, its overall radius shrank. The calculations suggest the Earth's radius decreased by about 40 kilometers, dropping from 6,410 kilometers down to its current radius of 6,371 kilometers.
So the rigid granite plates were literally pulled downward by gravity onto a smaller, shrinking sphere of magma. The planet shed a layer of its skin into space and condensed inward. That is terrifying. Billions and billions of tons of Earth's crust, glowing magma, and ancient atmosphere were blasted violently into the sky. So, where did it all go? And how did that chaotic spinning cloud of debris shape the solar system we see today?
Well, the trajectory physics of the blasted material dictates that it had three distinct fates, which brings us to the formation of the moon, our modern tides, and our seasons.
Right. Let's do fate number 1, escape. Some of that material was moving so incredibly fast, well over that 11.2 kilometers per second escape velocity, that it just blew right past Earth's gravitational pull and escaped into the deep solar system, becoming wandering asteroids and comets, never to be seen again.
Correct. Now, fate number 2 is what formed our closest celestial neighbor. The material that was ejected just slightly slower, fast enough to escape immediate fallback, but not fast enough to escape Earth's gravitational orbit entirely, became trapped. It formed a massive chaotic ring of debris circling the Earth's equator.
Picture Saturn's rings, but instead of ice, it's made of glowing red-hot chunks of granite and bubbling lava.
Over a geologically rapid period of time, orbital mechanics and gravitational accretion caused this dense ring of debris to clump together. The source specifies a very precise number here. Exactly 1.23% of the Earth's mass coalesced in orbit to form the moon.
1.23%. And this is where Meyer's small bang theory claims to elegantly solve one of the most frustrating headaches in modern astrophysics. For decades, scientists have analyzed the rocks brought back from the moon by the Apollo missions, and they found a massive, glaring anomaly. The isotopic signature of moon rocks, the specific chemical fingerprint of the oxygen and titanium isotopes inside them, is completely identical to rocks found on Earth.
And this is a significant problem for the mainstream giant impact hypothesis. In that model, the moon was formed when a Mars-sized alien planet, often named Theia, collided with the early Earth. But if Theia was an alien planet that formed in a completely different part of the solar nebula, it should possess a distinctly different isotopic signature.
Yeah, that makes sense.
The fact that the Earth and the Moon are isotopically identical has always required complex mathematical gymnastics and highly specific collision angles in mainstream models to explain how the two planetary bodies mix perfectly during the impact without leaving a trace of Theia's original signature.
But the SBT just bypasses the entire problem. Why are the Earth and the Moon chemically identical? Because the Moon is the Earth. It is literally made of the exact same 2-billion-year-old granite crust and underlying a mantle lava that was blasted off the Pacific equator exactly 66 million years ago. It's not an alien planet, it's our own shrapnel.
It is a beautifully simple Occam's razor solution to a complex isotopic anomaly, provided, of course, you accept the extreme thermodynamic mechanics of the explosion itself. Now, we must account for the third fate of the ejected material.
Right, the stuff that didn't make it to a stable orbit. Fate number 3, fallback. The source outlines that anything that didn't reach an altitude of about 324,000 kilometers eventually lost its upward momentum and fell back down. We're talking about millions of mountains worth of granite raining down from the sky, slamming back into the planet.
And the most famous of these fallback chunks relates directly to the demise of the dinosaurs. In mainstream science, the Chicxulub crater in Mexico is widely accepted as the impact site of an alien asteroid from deep space that triggered the mass extinction 66 million years ago.
But under the SBT framework, Chicxulub wasn't an alien asteroid at all. It was just a massive, incredibly heavy chunk of Earth's own granite crust. It got blasted into the high atmosphere, maybe hung out in a low suborbital trajectory for a few months while the Earth spun beneath it, and then gravity finally won. It slammed back down onto the planet. It was friendly fire. The Earth literally shot itself.
Myers suggests this perfectly explains why geologists find impact craters and scattered glass-like tektites all over the globe dating to exactly 66 million years ago. It wasn't a random, highly improbable swarm of space meteors arriving at the exact same moment. It was simply the Earth's own shattered crust raining back down after the small bang.
Okay, here's where the geometric consequences get really interesting. We've explained the moon and the meteor impacts, but what about the physical orientation of the planet itself? Like, the small bang was a massive explosion, but it wasn't perfectly symmetrical. It happened primarily at the equator, specifically in the Pacific region.
Right. Because the blowout was localized and incredibly violent, the physics of conservation of momentum dictate that it delivered a massive asymmetrical kinetic kick to the entire planetary body. Imagine hitting a spinning top hard on one side with a hammer.
The top tilts. The source calculates that this single immense sideways kick from the equatorial explosion forcefully tilted the Earth's rotational axis by about 23 degrees. The planet literally got knocked off kilter relative to the sun.
And that 23-degree axial tilt is the sole mechanical reason our planet experiences seasons. Before the small bang, a perfectly upright static climate. After the small bang, the northern and southern hemispheres now took turns tilting toward and away from the sun as the Earth orbited, instantly creating summer, winter, spring, and fall.
Instant seasons.
Huh.
And meanwhile, up in the sky, that newly formed moon of ours immediately started exerting its gravitational pull on the Earth, creating the very first lunar tides. So in the span of maybe a few months or years, the Earth went from a flat, static, tideless, seasonless swamp to a tilted, chaotic world with the moon violently pulling water back and forth across the surface.
But that raises a critical paradox that we must address. You just mentioned the moon pulling water back and forth across the surface. But as we established earlier, before the explosion, there were no deep oceans. There were only shallow 500-meter swamps. So how did the vast, deep oceans and the highly specialized creatures that live in them suddenly appear?
Okay, so let's look at the aftermath. The Pacific region of the granite crust is just gone, right? Blasted into space or pulverized. What happened to the rest of the 60-kilometer thick granite shell covering the planet?
It was catastrophically shattered. The shock waves from the small bang rippled across the globe, fracturing the remaining crust into massive, jagged continental plates. And remember, the Earth's radius was actively shrinking by 40 kilometers because of the lost mass. These rigid, flat granite plates no longer fit perfectly around the shrinking, curved sphere of the mantle underneath them.
It's like trying to wrap a standard basketball with the leather skin of a slightly larger basketball. It's not going to lay flat. It's going to wrinkle, buckle, and overlap.
Precisely. Meyer describes a chaotic reshuffling of the surface. Some of these massive broken granite plates were shoved violently underneath the exposed bubbling lava of the mantle as the sphere shrank. These submerged chunks of original crust, according to the FBT, are what mainstream geologists mistakenly identify today as subducting tectonic plates.
And what about the chunks of granite that didn't sink, like the pieces that stayed floating on top of the magma?
Those remaining floating chunks of the original granite crust became our modern continents. And remarkably, they make up exactly 29% of the Earth's surface today. The remaining 71% of the Earth's surface was completely stripped of its protective granite crust, exposing the raw, liquid basalt lava of the mantle directly to the atmosphere.
Wow, 71% of the Earth is raw, boiling lava. That sounds like an apocalyptic problem for anything trying to survive. But wait, where's all the water? When the small bang happened, the explosion was so hot and the pressure drop was so severe that it instantly vaporized all those shallow swamps and lakes, right?
Yes. Massive quantities of water were blasted into the upper atmosphere, and even into low orbit as superheated steam. But as the initial violence of the cataclysm subsided and the atmosphere began to cool, that water had to come back down.
And it came down hard. The text describes a torrential, global, icy rain, millions of tons of supercooled water falling from the sky directly onto 71% of the Earth's surface, which, remember, was currently a glowing sea of red-hot, exposed lava.
And the thermodynamic interaction between the torrential icy rain and the exposed mantle caused the lava to cool and solidify incredibly rapidly. When lava cools instantly underwater, it undergoes a specific physical process, forming bulbous, rounded shapes known as pillow basalt.
And pillow basalt is exactly what we find covering the bottom of all our deep oceans today. Mainstream science says it forms very slowly over millions of years at mid-ocean ridges. The SBT says it all formed almost simultaneously in a massive global flash cooling event. As the lava flash cooled, it contracted and shrank, forming massive, deep topographical basins. The torrential rain just kept falling, filling up these newly formed basins, and boom, the deep oceans were created.
It is a breathtakingly rapid terraforming event. Within a geologically microscopic time frame, the Earth transitioned from a shallow, warm swamp to a planet dominated by deep, dark, freezing, high-pressure oceans.
Which sounds like an absolute nightmare for anything living on the planet. I mean, 75% of all species died in this event, including all the big non-avian dinosaurs. The environment they were perfectly optimized for vanished overnight. But some things did survive, and this is where the SBT offers what I think is a brilliant, almost sci-fi biological deduction.
You're talking about the origin of deep-sea life.
Yes. Think about those crazy fish that live at the bottom of the ocean today. The anglerfish with the glowing bioluminescent lure on its head, or the gulper eel with a mouth bigger than its own body. If you follow normal, gradual evolution, how does a fish slowly evolve to survive in crushing, pitch-black darkness over millions of years? What's the transitional phase? Well, the SBT says there wasn't one. It relies on the concept of extreme mutants.
Exactly. In any biological population, genetic mutations are constantly occurring at random. Most extreme mutations are entirely detrimental to the organism and are quickly weeded out by natural selection because they simply don't fit the current environment.
Meyer refers to these extreme, unhelpful mutations as evolutionary junk.
Right. So if a bizarre anglerfish was randomly born in a shallow, warm, brightly lit 500-meter dinosaur swamp 100 million years ago, it would be dead in 5 minutes. Yeah. It couldn't see, it couldn't handle the temperature. It was an evolutionary failure for that specific environment.
Right.
But what if the environment suddenly violently changes overnight to mash the mutant? That is the crux of Meyer's biological argument. When the deep, dark, freezing, high-pressure oceans were suddenly created by the flash cooling of the small bang, almost all the normal swamp animals that got washed into the new abyss died instantly of shock and pressure. But those incredibly rare, bizarre, extreme mutants, the genetic junk that just happened to be born with abnormally pressure-resistant tissues or accidental bioluminescence, suddenly found themselves perfectly, accidentally adapted to this harsh new habitat.
It wasn't millions of years of slow adaptation to the deep. It was an instant environmental shift that allowed the freaks to inherit the abyss. They didn't evolve for the deep sea evolved around them. I mean, Meyer's model ties these anomalies together in a very neat narrative way. One single explosion explains the origin of the moon, the 23-degree tilt, the deep oceans, the end of the dinosaurs, the abiotic creation of coal and oil, and the survival of the anglerfish. But of course, creating a unified theory on paper is very different from proving the thermodynamic math and orbital mechanics hold up in reality.
True. It is the definition of a unifying theory, attempting to replace a complex web of disparate geological and biological mechanisms with a single causal event. But Meyer doesn't stop with Earth. The theory asks a broader question. If this violent depressurization happens to our planet, is it just a local statistical freak accident? According to the source, no. It is a fundamental cosmic life cycle.
Wait, a life cycle. So the SBT claims that this pressure cooker explosion isn't unique to Earth. It is a universal, inevitable process for any suitable planet that forms a solid crust over a molten core. Like every rocky or icy planet goes through this violent puberty.
Meyer suggests viewing the solar system not as a stable, isolated clockwork of planets peacefully orbiting the sun, but as an interactive, highly dangerous shooting gallery. And to provide evidence for this, the theory points directly to the Earth's fossil record. We all know about the dinosaur extinction 66 million years ago, but Earth has actually experienced 5 major mass extinction events in its history.
Yeah, the Big Five. If the Earth's own small bang caused the 5th one, what caused the other 4? Mainstream science points to slow climate change, prolonged volcanic eras, or maybe other random asteroids. The SBT says, look up. The other 4 mass extinctions were caused by other planets in our solar system reaching their pressure limits, having their own small bangs, and Earth getting caught in the cosmic crossfire.
Right, the text lists this crossfire chronologically, mapping planetary explosions to our extinction events. The first major extinction on Earth was the Ordovician, roughly 443 million years ago.
And the SBT claims this was caused when Uranus exploded. Uranus is an ice giant, so when its pressurized crust blew, it didn't send rocks. It sent massive clouds of giant ice debris hurtling through the inner solar system. Earth flew through this icy shrapnel cloud, causing rapid global freezing and wiping out early marine life.
The second was the Devonian extinction, around 359 million years ago. Meyer attributes this to the small bang of Neptune, another distant ice giant, causing a similar, though perhaps less intense, bombardment of frozen debris.
But then we get to the third one, the Permian extinction, about 252 million years ago. Geologists call this the Great Dying because almost 90% of all life on Earth was wiped out. It is the deadliest extinction in the history of the planet. And the SBT explains exactly why it was so incredibly lethal. It was caused by Venus.
And Venus is Earth's closest planetary neighbor, and it is a rocky, hot planet like ours. The thermodynamics of this event would be devastating. When Venus had its small bang, because it is so physically close to us in orbit, Earth was absolutely bombarded by massive, glowing, red-hot chunks of Venusian rock and highly toxic atmospheric gases.
It wasn't just ice, it was a point-blank shotgun blast of lava rocks and poison. It literally scorched the surface of the Earth, boiling the shallow swamps and burning the atmosphere. No wonder almost everything died. And finally, the fourth extinction, the Triassic, about 201 million years ago. The SBT blames Mars for this one. Mars had its small bang, sending its red crust to Earth, though the impact was mathematically weaker and less toxic than the Venus event because of Mars's smaller mass.
And this raises an important question. How does looking at the solar system as an interactive shooting gallery change our understanding of planetary evolution? It forces us to abandon the comforting idea of a peaceful, isolated Earth. Our planet's biological and geological history is inextricably linked to the violent physical maturation of every other planet orbiting our sun.
It's like living in a neighborhood where every single house has a faulty boiler that is mathematically guaranteed to explode at some point. You just have to hope you're hiding in the basement when your neighbor's house goes up in flames. This entirely recontextualizes the history of the solar system. And this brings us back to the human element of this deep dive. The journey of scientific discovery, and why mainstream science hasn't accepted this beautifully neat, unifying theory.
Before we conclude, let's briefly summarize the epic chronological journey we've analyzed today according to the small bang theory.
Right. So we started 4.6 billion years ago with a cooling, spinning ball of molten rock. The heavy iron sank to the core, the light granite slag floated and formed a solid crust starting at the upright poles. By 541 million years ago, that crust sealed completely shut, caulking itself with carbon and trapping all the Earth's outgassing pressure inside. For 475 million years, the Earth was a perfectly sealed, pressurized greenhouse, abiotically cooking up oil and coal deep underground, while giant, sluggish dinosaurs and tiny winged pterosaurs roamed shallow, tideless, seasonless swamps on the surface. And then, 66 million years ago, the tensile strength of the rock gave out. The equator shattered. The small bang blasted 2% of the Earth's mass into space, forming the moon, violently tilting the Earth's axis to create our seasons, and leaving behind massive flash-cooled basins that instantly filled with torrential rain to become our deep oceans, creating a new dark home for mutant deep-sea monsters.
It is an undeniably compelling narrative that connects seemingly disparate data points. However, it stands in stark, fundamental opposition to almost every established, mathematically tested tenet of modern geology, biology, and astrophysics. Meyer is acutely aware of this resistance. In the text, he frames his argument for future generations, asking them, how could you have missed this? He compares the struggle of gaining acceptance for the small bang theory to the historical struggles of Galileo, Darwin, and Einstein against the scientific establishments of their times.
Right, like when Galileo pointed his telescope up and said the Earth moved around the sun, the establishment locked him up. When Einstein proposed relativity, 100 professors literally signed a petition against him. Meyer argues that modern mainstream science is an ivory tower trapped in a self-reinforcing cycle of grants, textbooks, and peer pressure, unable to see the simple truth staring them in the face because they are too heavily invested in the old plate tectonics puzzle box.
And we must look at that claim objectively. While paradigm shifts do happen in science, comparing oneself to Galileo does not automatically make the physics of a theory sound. Rigorous mathematical calculations, orbital simulations, and independent verification of the thermodynamic models are required to move a theory from a fascinating narrative to accepted science. But regardless of whether the small bang theory ultimately holds up to that scrutiny, the source material serves as a powerful exercise in critical thinking. It is a reminder to not simply accept a theory just because it is written in a textbook, but to demand that our models elegantly explain all the anomalies, not just the convenient ones.
And that connects directly to you listening right now. Whether you are a student prepping for a geology exam, a professional looking to sharpen your lateral thinking, or just someone insanely curious about how the world works, the small bang theory offers an absolute masterclass in perspective. It shows you how someone can look at the exact same data everyone else sees. The same rocks, the same fossils, the same moon in the sky, but synthesize it into something radically different. It proves that human imagination and the willingness to question fundamental assumptions are the most powerful scientific tools we have.
It challenges us to look beyond the obvious. And I want to leave you with a final provocative thought to mull over, building directly on Meyer's premise of a cosmic life cycle. If the small bang is truly an inevitable phase of planetary evolution, a violent cosmic rite of passage that every suitable rocky planet must endure as its crust seals and internal pressure builds, what does this mean for our current search for habitable exoplanets in other star systems?
Oh, wow, yeah, because we are currently pointing the James Webb Space Telescope out into the dark, specifically looking for quiet, calm, blue, watery worlds just like ours, assuming that's where life is.
Exactly. But if the small bang theory is correct, a calm blue world is merely the end product of a cataclysm. The long, silent period before the explosion is a stagnant pressure cooker. Perhaps instead of looking for stable atmospheres and calm oceans, our telescope should actually be scanning the galaxy for the violent, expanding, glowing debris clouds of freshly shattered planetary crusts. The explosions themselves might be the brightest beacons, signaling that a planet is actively terraforming, preparing its oceans and seasons for complex, adaptable life.
That is incredible. We shouldn't be looking for the quiet garden. We should be looking for the exploding pressure cooker. It all goes back to that jigsaw puzzle we talked about at the start. If you only ever look at the peaceful picture on the box, you'll never realize that the pieces you're holding might actually belong to a much bigger, much more violent, and much more fascinating universe. Throw away the box and see what picture the pieces actually make.